Your brain contains billions of cells, all constantly learning, adapting, and rewiring themselves based on experience. And neural networks are built to copy this exact biological process, using the power of mathematics. Vector shield. Let's go. Layers of connected neurons work together to process data, just like your brain instantly recognizes a familiar face in a crowd. Neural networks do the same thing, but they find patterns hidden deep inside raw numbers. Weights control the flow of information between neurons. Each neuron takes a set of inputs, multiplies every one of them by a corresponding weight, adds a bias value, then sums everything up and passes it through an activation function to produce a single output. The equation is simple. Z equals 1 times x1 plus b, then a equals f of z. Repeat this process millions of times across thousands of neurons, all working in parallel. And that's what learning actually looks like inside a machine. Data moves through 3 key stages: input, hidden, and output, flowing left to right through the network with every single forward pass. Add more hidden layers between input and output, and you get deep learning, giving the network dramatically more power to understand complex, abstract, and high-dimensional patterns that simpler models simply can't handle. This entire process is called forward propagation. Inputs go in, every layer computes its result, and a final output comes out. Either a probability for classification tasks or a continuous number for regression problems. But how do the weights actually get set to the right values? Activation functions first add nonlinearity to the process, making complex learning possible. ReLU is the simplest, returns 0 or the input. Fast and highly effective in practice. Sigmoid and Tanh are used when outputs need to fall within a specific bounded range. Learning itself happens through a process called backpropagation. First, forward, make a prediction. Then measure exactly how wrong it was using a loss function. Then backward, nudge every weight slightly in the right direction and repeat the whole cycle. The loss slowly drops with each iteration, and the network gradually gets smarter. Vision systems, language models, self-driving cars, medical diagnosis, and complex games. AI is already here, woven deeply into the world around us and reshaping the way we live and work every single day. Input to weights, weights to layers, layers to output. That's exactly how machines learn from data, one tiny weight update at a time. If you found this helpful, make sure to like and subscribe to Vector Shield for more content just like this.